Hello everyone, I hope you're all well. This is Rashid Khan and you're watching my YouTube channel. In this video, I'll discuss the main concepts required for the topic called electricity. The first thing that you need to know is how to connect an emitter and voltmeter in a circuit. Remember, emitter is always connected in series, whereas voltmeter is always connected in parallel across the component. This thing is important here, across the component. What does it do? It measures current, while the voltmeter measures potential difference. Second bit that you need to know is what happens to the current and voltage in series and parallel circuits. Third thing we will need to know, and this is about resistance. When it comes to resistance, I can consider three different components. I can consider wires. Remember, if you use thick wire, then the resistance value will be low. You'll be able to carry more amount of current. Energy losses will be lower. Second option is I can use thin wire. If I use thin wire, then my resistance will be higher. It will carry less amount of current and energy losses will be more. Second aspect when it comes to resistance is resistors. When it comes to resistors, we can say we can connect them in series. If they are connected in series, then my resistance will increase. I'm talking about the total resistance that will increase. If the resistance increases, then the value of the current will decrease in that circuit. What if we connect resistors in parallel? So if they are connected in parallel, then my total resistance will fall down and more current will be carried in the circuit. Third thing that we need to consider when it comes to resistance is current. So I can say if you use large current, then your resistance will increase because this large current will cause temperature of the wire to increase, and as a result of that your resistance will increase. Second thing that I can consider is low current. So if I use low current, then my resistance will remain low because then the temperature it will remain almost constant. So this section is important because it talks about how resistance in a circuit can be changed. It can be changed by using different types of wires, using resistors in series or in parallel combination, or depending on the amount of current flowing in the circuit. I need to remember one more thing here. This is something that gets asked very often. If large amount of current is used, why is it that the temperature increases? So for this, you will have to remember, because more electrons will collide with positive ions. When they collide with positive ions, some Ke is lost as thermal. And if that's the case, this causes temperature to increase. Now, this is something that will not only apply to the wire, it will also apply to any component, for example resistors as well. So if large amount of current flows through the resistors, the temperature will increase. Why will this temperature increase? Because of these three reasons. Okay, let's move on to the second bit. You will need to know two main equations. So I recall equations. I'm talking only about potential difference calculations and the current calculations. One is Q equals I times T, and the other one is V equals I times R. Remember one more thing, they may ask you about the unit of this quantity called charge. So it's charge equals current times time. Charge is measured in coulombs. Current is in amps and time is in seconds. Second equation, this is my PD, this is my amps, which is my current. PD is in volts and resistance is in ohms. The symbol for ohms, and that's the symbol for ohms. This equation will be very, very important for your exam because there may be investigation questions on it. There may be investigation questions on it. So you'll have to find resistance of a component. There are three components that you need to know. First one is your fixed resistor. Second one is filament lamp. And the third one is your diode. So when you have to investigate resistance of a component, you'll have to memorize this circuit. This is my source of energy. This is my variable resistor. It's my voltmeter. I'll have an ammeter. So this is something that you'll have to memorize. I've left this location empty. This is the location where you'll add the test component. And we will have to measure its resistance. This is my variable resistor. So for this variable resistor, I can say R can be we'll have to look at these three things. 1, 2, and 3. So if I use this circuit, I can use my equation V equals I times R. And if I make R my subject, then it will give me R equals V over I. The value of V will come from here. The value of I will come from here. And if you plug these two values here, you can calculate the value of the resistance of this component. Sometimes what they'll do is they will ask you to investigate how the resistance of this component here changes with potential difference across it. What does that mean? This means we will have to change the value of V here. You will need to consider the value of R, V, and I. And I told you R can be changed. So I can say if the value of R increases, and this means this will receive more energy. Remember, it's a series circuit, so the energy from this source will be shared between them two components. So if you increase the resistance here, this component will receive more energy. This component will receive less energy, so the potential difference value will go down. Now, this is a series circuit. The total resistance will be given by these two resistances added together. So I can say my R total will increase, therefore the value of current will decrease. Very important to remember. Number two, I can say, what if I change the value of R, but this time I'm not increasing it, I'm going to lower it. If I lower it, then this component will get less energy. This will get more energy, and therefore this voltmeter reading will go up. Second bit, I can say I didn't change the value of resistance of this resistor. So second thing, I did not change the value of resistance of this component, so it will not change. However, the value of resistance of this component has now been lowered. So if I combine them two together, my total resistance would have gone down. If the total resistance goes down, then the value of current will go up. Reminder, I'm talking about these values over here, and I'm talking about these values over. So this indicates, my conclusion here is, every time R changes, V and I will change. So I can use this concept, and then I can collect the data here. Say here the values will be R, V, and I. I can have 1, 2, 3, 4, 5, and up to 6 values. Once I have those 6 values here, so every time I change the value of R here, the value of V and I will change. So I'll record these 3 values, and I'll use these 2, and I'll plot a graph of I against V. The graph can be plotted. So from these 2 values, we plot graph. So let's have a look at the types of graphs we can obtain from this data. I use I against V, and have a graph like this. I use I against V, I can have a graph like this. Again, for I against V, I can have a graph like this. You have to memorize these 3 graphs. The first one is for fixed resistor. This one is for filament lamp, and this one is for diode. So you have to remember, in addition to these 3 graphs shape, you have to remember resistance is equal to 1 over gradient for these graphs. So if that's the case, I can then say here the gradient of this graph is never changing, so I can say it has fixed resistance because it's a straight line. But I can see for this one here resistance is different, and as I move along this curve, the gradient is decreasing. So if my denominator keeps on decreasing, then I can say my resistance will increase. As V increases, number one, current increases. Number two, I can say as V increases, my resistance is increasing. For this section, I can say the same thing. Here, resistance has a smaller value. For this graph, I can do the same thing. At this location, the value of gradient is very small. So here R is large because gradient is small. At this location, I can say R is small now because gradient is large. Less steeper line, so gradient has smaller value. So if your denominator has smaller value, resistance will have a bigger value. Here, steeper gradient, this means the value of gradient is now large. Therefore, if gradient increases, then the resistance will decrease. You'll need to remember these three graphs, and this is something important as well. The next bit that we need to know is the sensors. So circuits which have sensors installed in them. So there are two sensors that you need to know. One has this symbol, and this is what we call LDR, light dependent resistor. So you need to remember when it is light conditions, in the presence of light, or we can say when light increases, my resistance will decrease. If light decreases, then resistance will. We've got another component, and this is what we call thermistor. Now thermistor is something which is thermistor, in case of thermistor, it works with temperature. So if my temperature increases, my resistance will decrease. If temperature decreases, then resistance will increase. So I can have exactly the same circuit like I had it before, but instead of variable resistor, I will now have a sensor. So the circuit will operate automatically rather than requiring a physical input. The same circuit, we can say I have a lamp here, emitter, and in this case, again, I can say the resistance of this component will change with light conditions. So for this, I can say during daytime, light will be more, and if light is more, then R will go lower. If R goes lower, the value of V will go up because it will receive less energy. This component will receive more energy. The value of current will go up, and I can say lamp will be more bright. Lamp will be bright. Then I can say during the night time, now there will be less light, and if there is less light, then the resistance here will be more. So I can say resistance will increase, this will obtain more energy, this will get less energy. I can say the value of V here will decrease because it's a series circuit. You'll have to combine them two resistances to work out the total resistance. So I can say the current will decrease, and I'm going to say lamp will be less. Lamp will be less bright. We can have a similar circuit, but this time, rather than having a LDR, I can have thermistor, and at this location I have a fan, say V, and I can say A. Now, in this case, I'll say daytime. What will happen during the day? The temperature will be higher. So if the temperature is higher, the resistance value will be lower. If the resistance is low, then the value of voltmeter will go up. There will be more current and the fan will work at higher speed, and speed will be greater. At night time, now the temperature will fall. If the temperature falls, resistance increases at this location. If the resistance here increases, that means the fan will get less energy. So the value of V will decrease, current will decrease, and then I can say fan speed will decrease. The last section that you need to know is the energy and power. So if we need to so if we need to calculate energy and power to a component, we'll have to remember a few things. There's one equation that is E equals V times Q. Recall three equations that you have learned previously. One is Q equals I times T, and V equals I times R. And the third one is power equals energy divided by time. Sometimes it will not be possible for you to work out the value of energy from this equation directly. You may have to calculate Q first using this equation, or you may have to calculate V first using this equation. So I can say I can get two more equations for E. One will be if I replace V equals I times R, and if I do that, I can have E equals I times R times Q, or other one will be E equals, where I'm going to put Q as I times T. That'll give me V times I times T. So in this case, I can then replace Q with I times T. And if I do that, I'll have another equation, E equals I times R times I times T, where I and I can be multiplied together, and that will give you I squared R T. In this case, I can replace V with I times R, and then I'll have E equals I times R times I times T, which gives me the same equation as I squared times RT. So you can see they are both the same equation. So if I look at it, I've got basically I've got equation 1 for energy, I've got equation 2 for energy, and I've got equation 3 for energy. There's one more, which is 4 equations. There are 4 equations that you can use to work out the value of energy. Out of these equations, this one and this one will be provided on equation sheet. So you don't have to remember these two, but the remaining equations will not be given to you. Now we know if I divide energy by time, I'll end up with equation for power. So I can say when it comes to the power, we can have various equations as well. If I divide V times I times T divided by T, it gives me one equation as P equals V times I. Then the second equation from here, I can say what I can do is I can replace V with I times R, and if I do that, I'll end up with P equals I times R times I, which is P equal I squared times R. So we've got two equations to work out the value of power, 1 and 2. And the third equation is our general equation, which is power equals E divided by T. Like I said previously, some equations will be given. This equation, and this equation. They will all be given to you on your equation sheet. So I can say provided on equation. The concepts discussed in this video are the most important ones that you must know for your exam. I'll make another video on this topic, going over some exam questions and to show you how you can apply these concepts to work out the answers for the given questions. I wish you all very good luck with your exam preparation. Thank you and take care.